Cyanobacteria blooms are a prominent issue which are becoming more and more common due to climate change, and they can pose many negative effects for the communities surrounding them. Due to cyanobacterial blooms, recreational services such as fishing, swimming, as well as ecosystem services are degraded by cyanobacteria blooms, as the algae creates unsafe water conditions for both humans as well as marine life. According to the CDC, algae blooms can pose many negative health effects in humans who have ingested cyanobacteria and can range from eye irritation and rashes in mild cases to seizures, liver failure, heartbeat issues, and neurological problems in severe cases. According to the state's 2024 Clean Water Initiative Annual Performance Report, Vermont has invested over $603 million in clean water projects since 2016, meaning they're also monetarily costly for communities, not just recreationally and provisionally. So, what is cyanobacteria? Cyanobacteria is also known as blue-green algae and can be found in fresh and salt waters, and it is highly abundant in Lake Champlain due to high levels of nutrient runoff. While cyanobacteria is not inherently dangerous, when warmer temperatures come around through spring and summer, a bloom is more likely to occur. This is an excess production of algae which ends up leaving cyanotoxins in marine environments, which end up being harmful. These blooms are becoming more frequent due to warmer temperatures thanks to climate change. So, how does cyanobacteria form? Cyanobacteria blooms are facilitated by factors such as warm temperature and high amounts of sunlight, stagnant water, and high concentrations of nutrients such as nitrogen and phosphorus. The nutrients in particular act as a food source for the growing algae blooms, which increases the size. When the large blooms die out, bacteria on the seafloor begin to decompose them using large amounts of dissolved oxygen, which ends up depleting oxygen levels in the water, creating dead zones, which are areas where marine or any form of life cannot be sustained. Dead zones have severe consequences for habitat as well as biodiversity loss, and many of the primary and secondary producers within ecosystems end up suffering, affecting food chains as a whole.
How does cyanobacteria impact marine ecosystems? Cyanobacteria blooms deplete oxygen in bodies of water during cell respiration when the blooms are growing, and when the blooms decay at the end of their life cycle. When an algae bloom decays, the bacteria that decompose the organic matter use up lots of oxygen in the water, which leaves other organisms in the marine ecosystem, such as fish, without oxygen, creating dead zones where marine life can't be sustained. This process of oxygen depletion is known as eutrophication. Zooplankton in particular are extremely sensitive to cyanobacteria, as diets consisting of 50% toxigenic strains result in a 100% mortality rate. Cyanobacteria can be associated with up to a 50% decrease in water flow, and since zooplankton are a food source for many secondary consumers, blooms have a food chain-wide effect on ecosystems.
So, what can we do to solve this problem? There are multiple solutions. The first solution is the implementation of permeable pavers. Permeable pavers are a form of green infrastructure that mimics the natural drainage pattern of water on open land, consisting of several layers to slow the flow of runoff towards bodies of water and filter out some of the nutrients. The biggest detriment to this strategy is that it has an extremely high cost of implementation. The second solution is crop rotation. Crop rotation is an agricultural practice that grows crops in phosphorus-rich areas year-round to help prevent the spread of phosphorus from these lands into bodies of water. The issue with this strategy is that it must be individually incentivized and is therefore hard to regulate and implement properly. The third solution is the implementation of riparian buffers. Riparian buffers are an herbaceous strip of woody plants, trees, and shrubs along the edges of bodies of water like rivers, streams, and lakes. The main goal of riparian buffers is to prevent nutrients like phosphorus from reaching the bodies of water. Riparian buffers have proven very effective in reducing phosphorus loads in water, but can have varying effects as buffer width and plant type within buffers affects function greatly. These are all great ways that the community can come together to solve the problem of nutrient loading in Lake Champlain. But what can we as individuals do to take action?
These are important steps to take to repair Lake Champlain, but you may be wondering, what can you do? We suggest looking for local community projects around you and volunteering your time to help build riparian buffers, for instance. Another position is becoming a lake monitor through the Lake Champlain Committee. All you have to do is submit an interest form at the website. You can do this by going to lakechamplaincommittee.org, going to their Lake Protection tab at the top, going down to Cyanobacteria, the LLC Cyanobacteria Monitoring Program, and then community volunteers in the first paragraph. This brings you to the interest form, and this is where you receive all the information and fill out the interest form. The criteria to continue is to have access to water, attend weekly training sessions, receive weekly emails, and agree to their protocols. As a monitor for the Lake Champlain Committee, you would submit photos and updates of blooms near you to the Vermont Department of Health Cyanobacteria Tracker. This record is then observed and used by communities and used for scientific purposes.